Okay, let's go ahead and go over your practice quiz here. Number one, write the equation of a circle with center -1, 3. So that's already my left side done for me. Opposite, opposite right there. And a point on the circle. Well, since I have the center and a point on the circle, that is the radius. And so I'm going to find the distance between the x-coordinates from -1 to -6. That's a total of 5. Okay, and from 3 to 7, that's a total of 4. So remember, it's Pythagorean theorem. 5 squared plus 4 squared equals r squared. Okay, and of course we want r squared on the right side. So 25 plus 25 plus 16 is 41, and that's why you see 41 on the right side for r squared. You could plot the points. You could use distance formula. I'm basically using Pythagorean theorem in my head by what I showed you right there. But if you need to write it out, either way, go ahead and do that. All right, complete the square to find the center and the radius. I just showed you shortcut. Okay, remember this is always half of b right here. So half of positive 14 is positive 7. Half of negative 18 is negative 9. And then what I really added to it that's not there is the 49 when I square the 7, and negative 9 squared is 81. So I really added, and that's why you see the plus 49 and plus 81 on the right side to the -5. Okay, so I skipped the step that I always show you in class of the plus blank in there. Okay, the blanks, this 49, this blank is the 81 here. All right, so you have 130 minus 5 is 125. That's why you then see the square root, because r squared would equal 125, so I have to take the square root of both sides. And 25 is a perfect square that goes into 125. 25 times 5, if you were to write it out, you can't do it off the top of your head. So you got 5 root 5 as my radius. Do not give me a decimal answer. The exact answer does not say to round, so you have to give exact answer. Number 3, write an equation of a circle with points on the end of the diameter. So these are points at the end of the diameter. The center is the midpoint. So I use the midpoint formula. I just did it in my head. 2 plus -2 is 0 divided by 2 is 0. And -2 plus 8 is 6 divided by 2 is 3. So there's my center, 0, 3. So obviously that means just x squared, and then y minus 3, because it's the opposite. Y minus 3 squared. Okay, and now I need r squared over here. Well, how do I get r? I go from the center that I just found to one of these points. Doesn't matter which point. So how far from 0 to -2? That's a total of 2. I'm going to square it. How far is from 3 to 8? That's 5. I'm going to square it. And that equals r squared. So I have 25 plus 4 is 29, which is y equals r squared, which is why you see 29 on the right side here. Again, if you need to use distance formula or plot the points and do Pythagorean theorem visually, go ahead and do that. Okay. Number 4, PD and PC, PB and PD are secants because it goes through the circle in 2 spots and comes out on one side or the other or both. Okay. Arc BD is 113, as you see labeled here. Arc AC is 45. We want the measure of angle P. So we know it's bigger arc minus little arc divided by 2, or I can do big arc minus little arc equals 2 times the measure of angle P, which is what I did, and then I divided by 2 on each side. Okay. And so 113 minus 45 is 68, divided by 2 is 34 degrees. Okay. So you say big arc minus little arc divided by 2 equals angle, or big arc minus little arc equals double the angle, or you can say outside arc minus inside arc if you don't want to say big arc minus little arc. Gotta have it memorized. Number 5, these are chords. Okay, we don't have a center of a circle because there is no circle, any dot there in the center and given a letter for it, so we don't know that those chords go through the center at all, because we also do not know that's a perpendicular. If we did, then we know, and we don't know it bisects either, so we wouldn't know if it went through the center either. So we just have two chords. The rule on two chords is you multiply each piece together. So if I change the colors, that piece times that piece equals that piece times that piece. So that's what I've written over here. 3x times 5, the two pieces multiplied together equals 10 times 12. So I went ahead and divided by 5, 5 on each side. Instead of multiplying the 3, 5 together to get 15, I see that 5 goes right into 10. So then I have that twice. 2 times 12 is 24. Now, really, I could have stopped right there and said 3x equals 24 and stopped right there because it says solve for the length from B to E. Well, B to E is 3x, and I already know 3x is 24. But if you were to go ahead, if it didn't work out like that, you solve for x, you get 8, and then you go ahead and plug it back in, and BE is 3x as it shows here, so 3 times that 8 is 24. That's what I'm showing you right there. All right, number 6. We know since this is the center of P and it's perpendicular, so it's going through the center, then we know it's a perpendicular bisector. You need to know that. So they give me those two pieces, the length from A to M and the length from M to T. So since we know it's perpendicular bisector, we can just set those equal each other, which is exactly what I did right here. Set them equal each other. So you just subtract the x across, gives you 2x, add the 2 across, gives you 10, divided by 2, and you get x equals 5. Always go back and read it and make sure that that's all they were asking for. Number 7, we have arc DEC is 67, arc AD is 97, and find the arc of BC. So that's dealing with these two arcs here. And we know the rule is if you add those two arcs together, divide by 2, you get this angle right here. Well, they didn't give me that angle, but I could have easily found that angle as I showed you right here because I have a linear pair. They gave me that 67 there, so that forms a linear pair. 180 minus 67 is 113 degrees. So now I do have that angle. Okay, and so just so you know, this has been a DCAS problem before. Okay, that's why I have that here. Seen on the DCAS. All right, so what do? 97 plus x equals double the angle of the 113, or I could have done 97 plus x divided by 2 equals 113. Either one's the same steps to solve it. So I double 113, got 226, subtracted 97 across, and you get 129. Okay, and I could check that if I wanted to. Remember, 113's got to be the average. How far is it from 97 to 113? That's a total of 16 plus 16. So then I just add 16 to that. That's another shortcut method. 16 plus 113 is 129. Okay, so that's another way you could do that. And that would be your work you'd show. You'd show me plus 16 if you're going to do it that way. Okay, your choice. All right, number 8. Chord AB is parallel to CD. So I put the parallel symbols on it. Whenever I have parallel chords, I know that in between those parallel, their arcs are the same. So that's why I immediately put the X and the X there. You got to have that memorized. Okay. That also means, just so you know, that they were equidistant from the center, but we don't have a center point labeled here, so I can't mark that in there. But if they're parallel chords, they're going to be equidistant from the center. Okay. Arc CD is 100. I put that in there. Arc BD is 63. Well, since I know they're the same, I know the other one is 63. That's really what this is testing here. See that you know that inside the parallel segments chords there, that those are equal intercepted arcs. And it asked me to find, therefore, arc AB. I just call it Y since I already put down the X for the other ones. So I have 63 plus 63 is 126, plus this 100 is 226, and then plus the Y would add to the 360. So it adds the 360, subtract the 226 across, and you get 134. Okay, so there's arc AB, 134. Number 9, we are finding the area of the shaded region. Okay, so I have the full circle, area of the full circle, which is pi r squared, minus the area of the triangle. Okay, that's what I'm doing, and that gives me the shaded region. Well, tells me right here, radius is 4. So I put a 4 and a 4 there. There's my center, 4 and 4, put radius there. Okay, so pi 4 squared is 16 pi. That's the area of the whole circle. And now we subtract off the area of the triangle. Well, it tells me angle BAC is 60 degrees. Okay, so that's 60 degrees right there, which makes this 30 because we know this is 90 because it goes to the ends of the diameter. So it's half of its intercepted arc of 180 degrees. So I have a 30, 60, 90 special right triangle. Okay, so you got to remember your special right triangle rules. Okay, so we know the 30-degree side is always half of the hypotenuse. So remember, here's my hypotenuse across from my right angle. So the hypotenuse is 8, half of 8 is 4. So it puts a 30-degree side at 4, and we know the 60-degree side is root 3 times longer, which is why I have 4 root 3 there. Now I do the area of a triangle. The area of a triangle, you should already know, is 1/2 base times the height. The base and the height always have to be connected at the right angle. So that means there's a height and there's a base right there, connected at the right angle. So I do 1/2 of 4 root 3 times 4. So half of 4 is 2 times 4 is 8 root 3. Okay, and then it's area, so don't forget put parentheses around the whole thing, and then units squared for area. Number 10, find the circumference of a circle. Circumference formula is 2 pi r, which means all I need is the r. Well, it tells me the area is 121 pi square inches. So I need to know the area formula of a circle, pi r squared. You learned all this in middle school. Okay, so it tells me the area is 121, so I go ahead and substitute in 121 pi there. The pi's then cancel out, so I get r squared equals 121, take the square root of both sides, and I get r equals 11. Now I can take that r equal 11 and substitute it in there. And so I get circumference equals 22 pi inches. Go back and find the units. Inches, it's not inches squared, that's area. Circumference is just a straight distance around the circle. So it's degree 1. Okay, last but not least, we have a rotation of 90 degrees following a reflection over the line y equals 0. So remember, this is function notation, so we go right to left. You have to remember that. You get a different answer otherwise. Okay, so reflection over the line y equals 0. You should know y equals 0 is the x-axis. Okay, and so you've been practicing this over and over. Reflection over the x-axis of xy maps onto x negative y, which is why you see that right there for the first image. And we're doing the reflection over y equals 0 first. So that's x negative y. So I apply that to these points right here. Okay, so it means take the opposite. The x coordinate stays the same, just do the opposites on the y. So that's what you see right here. Then it says do a rotation of 90 degrees. Remember, 90 degrees is counterclockwise, positive degrees is counterclockwise. And remember that if I'm going 90 degrees from here to quadrant 2, I have to first reflect over here, which then is that rule, x negative y, and then over the line y equals x, which means to switch them, the x and the y. So that's why it says negative yx right here. So now I apply this negative yx to those image points, those first image points right there. And then you get these answers right here. Okay, so there's your final answer. So you could get, if you got the first part right, got these 3 right, but then missed these 3, you get half credit. Okay, and here, now in the DCAS, you get no credit. They only care about the final answer. Okay, you got to get both right on the DCAS. All right. So just to have you, if you want to check to see if those made sense, you could actually plot the original points. Okay. So you have -4, -6, right there, -2, -5, and 5, 5. Okay, it says reflect over the x-axis. So that puts this up here, and this up here, and this down here. And this is rotate 90 degrees. So I rotate this 90 degrees. That's going to put it down here in quadrant 3, and up in quadrant 1. So are these first 2 points in quadrant 3? Yes, they are. Is this last point in quadrant 1? Yes, it is. So if you have that, that's an easy way for you to check that your answers make sense because you have them in the right quadrants. Okay. All right. That goes ahead and explains everything you know. If, for example, this was a y equaled 2 or y equaled -1, then you actually have to plot the points and reflect and draw that line y equals 2, for example, and actually count and put the new coordinates in right here. There's no rule, or the only time we have a rule is if it's over the y-axis or the x-axis for lines, horizontal or vertical line. If it's anything else, y equals 1, x equals -1, then you actually have to draw the line itself and then reflect it over it and put those new coordinates in there. All right, now we go ahead and answer all questions. 16 minutes.